Let's start with objective 2, HC Verma from friction chapter. My name is Hitesh Sharma and start with question number 1. Let Fn and small f denotes the magnitude of contact forces, normal forces and friction force. Obviously contact force is the resultant of normal and friction. Then which of the following is correct? That F, which is the total contact force, will should be greater than normal force. So obviously it is the resultant, so it should be greater than normal force, because the angle between them means friction and normal is 90 degree. So F is nothing but this square plus this square whole root. Okay, so obviously as all three are non-zero, so F must be greater than Fn. F must also be greater than friction, and this normal should be greater than friction is not necessary. Okay, mu can be greater than 1, so it is not a correct statement. D, that force, total contact force, should lie between sum and difference. Obviously it is the property of a triangle that the resultant should be smaller than the sum of magnitudes of other two and should be greater than the difference of magnitude of two vectors. Okay, so A, B and D are the correct answers. In the next question, the contact force exerted by a body A on another body B is equal to the normal force. So we can say friction must be zero, as contact force is the resultant of friction and normal, but it is given that contact force is equal to normal, so friction must be zero. Friction must be zero. The surfaces must be frictionless. No, it's not necessarily. Even on the rough surface, friction force can be zero. So option A is not correct because must is here. Okay, it is not correct. Option B, the force of friction between the bodies is zero. Obviously yes, this is right. The magnitude of normal is equal to friction. No, incorrect. The bodies may be rough but they do not slip on each other, or neither they should have tendency to slip. Okay, they are neither slipping nor have tendency to slip. Option D is correct, almost correct. Okay, they do not slip means they are not having tendency to slip. Okay, so this is how option D is correct. Next is mark the correct statement about friction between two bodies. Static friction is always greater than kinetic friction. No, static friction has a range from 0 to mu sn. So it may be smaller than or greater than also. Kinetic friction is always greater is the wrong answer. So A is incorrect. Coefficient of static friction is always greater than, yes, this is a theoretically part, true. So mu s is always greater than mu k. Limiting friction is always greater than kinetic friction, yes, because limiting friction will be mu s n and kinetic friction is mu k n. As mu s is greater than mu k, we can say mu s n or limiting friction should be greater than mu k n, which is kinetic friction. Option D, limiting friction is never less than static friction. Yes, we can say limiting friction is the maximum value of static friction, so option D is also correct. In the next question, there is a block placed on a rough floor and a horizontal force F is applied on it. The force of friction F by the floor on the block is measured for different values of F. A graph is plotted between them. We can say as F increases till the moment it don't reaches the limiting friction, friction will also increase and it will remain equal to F. So friction will be equal to the applied force till the moment the system is not moving. Okay, so obviously when these forces will be equal, the initial slope of the graph will be 45 or 1. We can say this is the diagram. F is equal to friction if F is less than mu s mg, and F friction will be simply mu k mg if F is greater than mu s mg or limiting friction. Okay, so the graph will be like this till friction is equal to or till force exceeds mu smg. As soon as it exceeds this value, the friction will become mu kmg or kinetic friction, and it will remain constant. So the correct option are C and D. The graph has a straight line with slope for small values of f and a straight line parallel to x-axis for large values of f. And obviously there is a small kink when the setup is moving from static to kinetic friction. Okay, next is consider a vehicle going on a horizontal road towards east. Neglect any force by the air. The friction force on the vehicle by the road may be in any direction in which it is accelerating. Okay, so friction is the only force that can provide the acceleration to the vehicle on a horizontal surface. So we can say if it is moving towards east and accelerating, then the friction will be towards east is zero while it is moving with uniform velocity. Obviously, yes, both A and B are correct. Must be towards east? No. Must be towards west? No. Okay, it will be towards west when the vehicle is retarding. It will be towards east when the vehicle is accelerating, and it will not act when the vehicle is moving uniformly or has no acceleration. Okay, thank you.